Hey guys, this is the video about law of cosines. We're going to start talking about what we learned about from law of sines and what those three arrangements of like angles and sides that we could use when we were doing law of sines. And so we had the angle side one where we knew one angle and then another angle and then a side that was not between them. So something along the lines like if we knew that was 30 degrees and this one was 110 degrees, and then this side over here was 15 feet. That was the angle side, and then we could use that to find missing side. Like we could find this side from there. We also had the angle side angle, so we knew an angle and then we knew the side between them and then we knew the next angle. Again, so something along the lines, if we knew this was 70 and this one was 30 and this side was 10 feet, we could use that to find another missing side. And then we had the last one, which was the tricky one, which is this side angle. So if we, oops, I wrote that wrong. Side angle, so that two sides, but then the angle not between them. It's like if we knew this was 11, this was 20, and this angle was 10 degrees or something like that. That was our ambiguous case one. So ASA, and then we had the SSA. So we could find that missing angles, but we had to watch out for the other possible values there. So those are the three we learned already. Oh, I messed that up. Dang it. No, I didn't. I got that. So what are the other ones that we haven't talked about yet? And so here we knew two angles and one side. What if we knew all three angles? Right. Here we knew, two sides and an angle. What if we knew all three sides? Side by side, side. And then we've talked about knowing two sides and one angle that's not between them. Well, what if we knew two sides and the angle that was between them? So SAS. So law of cosines is going to apply to two of these, and the third one is actually impossible to know anything about, and that's the angle. I can draw another triangle with those exact same angles, but completely different size. Like if we think about just rescaling this triangle here, I can shrink it down, make it a tiny little triangle. It's got the same angles, but it has completely different side lengths. Or I can make it really big, same angle measures, but completely different side lengths. So knowing three angles in a triangle is not enough for us to be able to find the side lengths. It's just not enough information. So we will not deal with that. We're going to talk about how we can use the law of cosines to help us figure out all the angles in this triangle, or we could use the law of cosines to figure out these other angles and then this missing side in this triangle. So the standard form for law of cosines is a squared equals b squared plus c squared, and then minus 2b, so 2 times b times c times the cosine of angle A. Then we have two other versions of that, and we're just kind of moving the letters around. So if I want to find b, I would need to know a squared plus c squared minus 2 times a times c times the cosine of angle b. Or if I wanted to know c, it'd be a squared plus b squared minus 2 times a times b times cosine of c. So just notice, like when we want to find a side, we need to know the other two sides, and they show up here again, and then we need to know the angle across from it. So we kind of like, if I know this angle, that means I could find this side here. But I'd have to know the other two sides. And then what we end up doing is there's another form of that. Basically, what if I wanted to find the angles that go with this? Like, what if I wanted to figure out angle A? Basically, we're just going to solve for that. And so I need to move all this stuff here to the other side. So we can do that by just subtracting these first. It's like the cosine of angle A. So I just take A squared minus B squared minus C squared. And then I'm going to divide by this stuff to get that out of there. So over negative 2BC. What you can do is make this a little bit simpler though, because we have this negative here that we're dividing by. We would just divide all these by negative 1. And so what it ends up looking like is this. So the B squared would become positive, the C squared would become positive, the A squared would become negative now. Ah, Lord. And then we'd be over positive 2BC. So that's a simpler version of that. So if I want to know the angle, I need to know all three sides. But just notice how it's, B and C are here, B and C are here, both times. We just have the one time over A. So I'm just going to rearrange that for the other ones. So cosine of B would be A squared plus C squared minus B squared over 2AC. And then the cosine of C would be A squared plus B squared minus C squared all over 2AC. To AB. So again, I always notice that, I know B, I know B, I know B and C are here. Or I'm sorry, I know B and C are here, and then A is by itself when it's it's the different one when I want angle A. If I'm trying to find angle B, side B is the one that's kind of by itself, but then A and C show up twice. So just in general though, if you're looking for a side, you need the other two sides. And the angle across from the side you want, or angle opposite. Okay. So use this version of the formula to help you find sides. And the standard form is to help you find sides. The alternate form is to help you find angles. And you need all three sides. So obviously the formula here is a lot more complex looking than law of sines, but it's nothing you need to memorize, but just be able to use it. And kind of again recognize like when you use this. So that's gonna be the tricky part as we move forward. Is like do you use law of sines or do you use law of cosines or do you use regular trig on the problem? Again, the law of cosines is for non-right triangles. If it's a right triangle, you're just going to use Pythagorean right there, and we're going to use this regular trig. So let's try a problem. So I've got some measurements here on this triangle. So what does nowhere here just specifically does it say it's not a right triangle, but so in that way we just kind of assume that it's not a right triangle. Again, across from the side is the angle, so that'd be angle A down there. And across from side B would be angle B, and across from side C would be angle C. So we want to find all three angle measures. Doesn't matter which one we start with, but we need to find all three. I'm just going to start with A. So since I'm trying to find an angle, I'm going to use the alternative form. I'm trying to find angle A. I'm going to start with cosine of A. So it's equal to B squared, which is 14 squared, plus C squared, which is 19. Oh, no, either way. Either way, it doesn't really matter because that's adding, so I can just put them in any order. And then minus A squared, and so that one does matter. All over 2 times B times C, which is 14. So you could put this in your calculator and figure out what mess this is. It's not going to be something pretty, so I really don't want to do that. What you guys need to know about both of these formulas, per se, is that they're not done. Like, this is the cosine of A. It's not A. It's cosine of B. It's not B. Cosine of C. It's not C. Or like all of these here, that doesn't say A is this. It says A squared is this. So none of these are done, per se. We have one more step that we need to do in order to finish this. It's we need to uncosine this problem. And so we're going to take the inverse cosine of both of these sides. So the A value really is this. And this is what I would type in my calculator. Now, your calculator's going to get confused if you do type it that way because the numerator and the denominator are both complex, and so you're going to need to wrap this in parentheses, wrap that in parentheses. So be really careful as you type that in. I got 22.07. Let's just round this to the 10th. I got this 0.075 dot dot dot. So we'll say A is 22.1 degrees. That's an angle, so we're fine, so put degrees on it. So essentially going to do the same thing to find the other two. So if I find B next, so the cosine of B, so that's going to be A squared plus C squared minus B squared all over 2 times A times B, C. So can just kind of, the 8 and the 14 both show up here. All right. That's the one that's across from the side the angle we want. It's the kind of lonely one. And so then B would be the inverse cosine of all that. I do want you guys to show me the original part and then the solved part. got 116.8009 dot dot dot. So I'll say B is 116.8 degrees. And then I'll find angle C. Kind of worked myself out of room here. So 8 squared plus 19 squared minus 14 squared over 2 times 8 times 19. Again, make sure as you're typing that in, you're wrapping those numerator and denominator in parentheses. Did not say that last time. That gave me 41.123 dot dot dot. So let's say that C is 41.1 degrees. It's like, so how do we know if this is right? All right, so we can check this. This one's actually pretty easy to check. We can just add those up. 22.1 plus 116.8 plus 41.1. 22 plus 116 is 138. 138 plus 41 is 149. And then we have 0.1, 0.8, and 0.1, which would have another 1. So 179 plus 1 would be 180. So it does check. I'm going to go ahead and say that you guys don't need to do all 3 of these this way. I'm going to be okay if you just find the first 2 angles using the law of cosines, and then find the third one just subtracting from 180. Good Lord. Okay, so whether that's you find A and then B and then use 180 to find C, or you find A and C and then use 180 to find B, it doesn't matter. Just find 2 of them and then use 180 to find the third one, so you don't have to do that over and over again, because it is kind of a bear to write all that out. So let's try a different one. So I was finding the angles using law of cosine. Oops. So labeling up what I know, find the unknown side and angle measures. So essentially we're solving the triangle here. In order to do this, we have to find side A first. In order to find the angles, we have to know all 3 sides. And so if we don't know what side A is, then we can't find the angles. So just FYI. So how do we find a side? Right. We need to know the other two sides, which we do, and then the angle opposite the side we want, which we know, right? So we know angle A, and then the other two sides. So, Lord. A squared is equal to B squared plus C squared minus 2BC, so B squared plus C squared minus 2 times B times C, or times the sine of angle A, which is 25. So again, we could type all this in our calculator. It's just going to give us something gross. I don't want to do that yet because this is not solved for yet. So that first step, that really the only step we need to do is to square root both sides. So A is equal to the square root of all that. You should not need to do anything special with parentheses here because that's all on one level. Just make sure you're typing that in all right. I got 11.5634 . We'll go ahead and round this to the 100th like we've been doing the sides. So 11.56, that's in centimeters. Oh, good Lord, why did I write sine? Wait. Hopefully you guys caught that. Thought something fell off. Fix that. There we go. That is 5.40717 . All right, so 5.41 meters. Now that we know side A, we can find angle B or angle C. It does not matter which one. I'll just pick B. So cosine of B. So we want the other two sides. So 12 squared plus 5.41 squared minus the side that we're looking at, which is B9, all over 2 times 12 times 5.41. So the unfortunate thing here is that we are using the number that we found to find something else, and it's got some rounding in it. So this is going to have a bit of error in it, but there's nothing really we can do about that besides holding more decimals, which we don't want to do. But, so we're going to uncosine both sides. Again, make sure you wrap in parentheses. And I got 44.7138 . So we'll say that B is 44.7 degrees. Again, on a problem like this, I'll say you go ahead and find that third angle using 180. you don't need to, so basically on both these problems, I just need you doing two maths. Like, so we find one angle, find another angle, then we can use 180 to find the third, or here we find one side and find another angle, and then find the last angle by using 180. So we don't need to do all three things using the law of cosines.
I'm making a video right now.
So there's our angles C. All right, I'll do one last problem, and then we'll be done with this. So an airplane is flying 15 degrees above east. So here's like our east-west line. It says 15 degrees above east. What that's talking about here is that we know this angle is 15 degrees. It flies for 350 miles. So that this line here is 350 miles. Not the horizontal one, but the tilted one. And turns straight north. So let's talk about this line here. And flies for 475 miles. How far is it from where it started? So what that's referring to is this line. So that's straight line distance. We want to know that. So if we're looking for a side, we need to know the two sides and then the angle across from it. Okay. So we need to know how big this angle is here in order for us to do this. Right? So using this version of the law of cosines, we need to know the two sides and the angle opposite of it. So how does knowing that 15 degrees help us know that angle? So a couple ways to think about this. One, we could think about that east-west line that's here, and that goes, then we have our 350-mile line that goes there. We could put another east-west line there, and if this is 15 degrees, we would know that this is 15 degrees. And then we have the north-south line that goes there, and north-south would be perpendicular to east-west. And so we know that's 90. And so then we can know the total angle is 105. There's one way we could figure that out. Another way to think about it is just a little bit more abstract. That if we, again, kind of start off with that horizontal line there that goes through the angle. And so I have this horizontal line, but instead of it being I'm going to try to draw that a different way. So I have this horizontal line here, but instead of being flat, it's tilted down 15 degrees this way. So we would know this angle, should be 90, but now we're tilting that line down 15 degrees. So it's just going to be 15 degrees more than 90. So we can kind of think it out that way. But either way, we end up with 105 for that angle measure there. So now that we know that, we can just find the question mark, like whatever you want to call it, A, B, or C, doesn't matter. I'll just call it A. So I'll say A squared is equal to B squared plus C squared, whichever one is B and whichever one C does not matter. Minus 2 times those numbers times the cosine not sine, of angle A. So I wanted to square root both sides of that. you don't need to do anything special when you type that in, just be careful. You want to double check your numbers before you hit enter. That gave me 658.925 ... So we'll just say about 659 miles. All right, so there's examples of using the law of cosines to find sides and angles. There's another part here with finding an area of a triangle. You can find that on the second video that's like right next to this one in the Google Sheet if you're wanting to do that. But otherwise, we'll just do that on Monday when I see you guys. Be safe.